The purpose of this video is to just help you review some of the rules for graphing and quick sketching of graphs that you should know for success in AP Calculus. So I'm going to go over the first one with you. I'm going to look at y equals negative the square root of x plus 2 plus 1. So I recognize this as a square root that is negative. And so a negative square root is a half parabola that goes down through quadrant 4. I also recognize that it's got a plus 2, which tells me I need to move it to the left, and a plus 1, which means I need to move it up. And so I'm going to move this graph 2 to the left and 1 up. And the resulting graph would be like that. All right, the range of this graph needs to go from its low value to its high value. Now this just keeps going lower and lower and lower and lower, so its lowest value is negative infinity. And the highest value this graph stops at, we can see that it stops at the number 1. And so this stops at a closed circle on 1. That's the range. The domain of this graph is based on the fact that square roots cannot be negative or 0. And so I take what's in the square root, which is x minus 2, and I set it greater than or equal to 0, which means, x plus 2, and then I subtract 2 from both sides. And so the domain is x must always stay greater than or equal to negative 2. All right, the next one is also going to be a square root, but I want to show you something a little bit unique about that. So here's a square root that is going to be 3 minus x, and then minus 4. All right, 3 minus x. Now this is backwards, and so it's going to be important that you rewrite this in the correct order. So some people will take the opportunity then to change that to negative x plus 3. But that's a little bit deceiving and it's a little bit sloppy, and that's not going to be the way that you want to write that. Instead of writing negative x plus 3 with a negative, you're going to want to write it this way. Negative x minus 3. Now that's still the same thing, but the negative is written outside of parentheses. If we distribute the negative, we can verify that it was the same thing we started with, but it's better to write it this way because it's going to help you shift and translate in the correct direction. Otherwise, you end up going in the opposite direction. So this is another square root. The negative here is on the inside, and so that tells me that my square root, which normally would be a positive heading out through quadrant 1, is now going to be heading out, reflecting over the y-axis and going through quadrant 2. Okay, going to be shifting that way. That's that negative reflects it over the y-axis. Then I have a minus 3, which is going to move this 3 to the right, and then 4 down. So I'm going to go 3 to the right, I'm going to go 4 down, and my new graph is going to go from that critical point right there. So I'll erase this and then go, and that's a sketch of this graph. All right, the range of this one, the lowest point of this graph is negative 4, so negative 4 less than or equal to, because it is a closed circle. And the highest point of this graph, even though it's going to the left, it's always increasing, it's going up. And so this would be infinity without the equal to bar under infinity. The domain of this one, you take what is in the square root, okay, not the negative 4, just what was in the square root. And so we're going to take what was in the square root, which is negative parentheses x minus 3, and set that greater than or equal to 0. Divide everything by negative 1, which flips the signs around. And then add 3 to both sides. X is less than or equal to 3. And that is your domain for that particular function here. All right, the next one I want to look at with you is an exponential. So y equals e to the negative x minus 2. So e to the negative x, I'd like you to draw your asymptotes for that one as a highlighted line, okay? And then e always hugs that asymptote, and then it goes through 1, and then it turns towards infinity. All right, the negative is inside the function, which means I want to reflect over the y-axis. And so my reflection is going to come down like this. And so I'll be reflecting into different quadrants. And then I want to shift the whole thing down too. So I want to shift the asymptote down too, and the entire rest of the graph down too as well. So again, I'm just using the features that help me, erase. So I don't have to use a regular eraser. I'm using my digital to clean up my graph here. And so my new graph, my final graph, ends up coming down. Oops, I'll change colors. Come down, cross through that position, and then hug the asymptote. I didn't like how that turned out. Try that again. All right, come down, make sure you cross through, and then turn the corner. There we go. All right, the lowest value of this graph, the range, would be -2, but it's not a closed circle there. It's an asymptote. And the highest value, because it's pointing up to infinity, so the range of this would be -2 to infinity. The domain, there's no denominator, no square root, no logarithm, so the domain is all real numbers. All right, the last one I'll look at with you, let me just clear some space here, is going to be an inverse graph. And so let's take a look at, all right, one final graph we'll look at, and this time I'd like to do an inverse with you. So I recognize this is an inverse because of the fraction, and so inverses are going to have asymptotes, and I've got one along the x-axis and one along the y-axis for starters. And then I see that I've got a +1 right here, which means I'm shifting to the left. And then I also have a +2, which means I'm shifting up. So I'm just going to shift my asymptotes before I draw my full graph. So I'm going to move my asymptotes to the left and up, and then I'll sketch the graph in the right place here. Okay, so my asymptote now moves to the left. Let's see here. Okay, here's an asymptote, and then my other asymptote's moving up too. And then my graph, because it's an inverse shape, I'll have a branch up here, and then it in this lower section. Okay, you don't have to be super picky about where all those dots are. I'm just wanting to know the general position of that. All right, so let's look at the range here. Because this is 2 branches, you're going to have 2 separate ranges. I'm going to have a lower range and an upper range. So my lower range, it is going down all the way to infinity, and it will never be higher than 2. My upper section has its own range. Okay, so separate ranges for separate sections. And so this range has a low value of 2 and a high value of infinity. So basically, if you put the 2 ranges together, you've covered everything from negative to infinity, but you've skipped over 2. So one way to combine those 2 ranges would be to write them y is not equal to 2. That's a simpler way to combine the 2 expressions. The domain of this would be something, because it has a denominator, we need to make sure that we guarantee the denominator will never be equal to 0. So we need to exclude the number -1 from our screening here and not let the number -1 in, because it would violate the domain restriction of not being equal to 0. So that's a sample of an inverse graph, and being able to sketch that as well.